Now that we've talked about functions of several variables, we're going to talk about something called partial derivatives. So basically, how do we take a derivative when we have a function that has more than one independent variable? So let's start out with the idea that, like we saw before, z is some function of x and y. Now, if I said find the derivative of this function, it doesn't quite make sense anymore, right? If I have y as some function of x, if I said find the derivative, well, you would assume that y prime means that you're taking the derivative of this with respect to x. However, up here, we have two independent variables, which means instead of just having one first derivative, we actually are going to have two first derivatives. And in the case if we had three independent variables, we'd have three first derivatives. Now, just like before, there's kind of two notations that you're going to see here. So let's start with this, notations. The first one's kind of like the prime notation that we just did a second ago, like y prime. The problem is I can't use z prime here because that's not telling me what I'm going to take the derivative with respect to. So I'm just going to say the function name here is f. So one notation, this is kind of like our prime notation, we would do f sub x of x and y. So here we have a little subscript, and this is telling us we're taking the derivative with respect to x. F sub y says we're going to take the derivative with respect to y. Now we also have our differential notation, right? That's a horrible looking d right there. We have our df dx or dy dx or whatever our variable is there. That was our differential notation. Now that also, we have one of those over here, but we're going to write our d's a little bit different so we can show that it's not a single variable. The way that you write the d's are kind of weird. It kind of goes up like this. So this would be df dx, and this would be df dy. So both of these stand for the derivative of f with respect to y. Both of these stand for the derivative of f with respect to x. So these would be, both of these would be our first derivatives. Okay, now the problem is, what happens when we get to our second derivatives? How many second derivatives are there? Well, there's actually a lot, because remember how we find the second derivative, we take the derivative of the first derivative. Well, we have two first derivatives, so we're going to have to take the derivative of both of these guys. And since we have two independent variables, we're going to have to take the derivative of both of these with respect to both of the variables. So that gives us four second derivatives. So let's start with, I'm going to do both notations for this. I could take f sub x, right? This is the derivative with respect to x, and I could do the derivative again with respect to x. So that would be f sub x of x and y. Now, here's where it gets a little weird. Remember how we found the second derivative with our differential notation? If we have, say, dy dx, and we do the derivative again with respect to x, our notation looked like this, d squared y dx squared. Well, the same thing's going to happen with this one. So if I have the partial of y with respect to x, and I do the partial with respect to x of the partial of y with respect to x, it's going to look exactly the same. So we get the partial squared y over partial x squared. So the notation just goes along the same way that it did before. The next one's going to be a little bit trickier. So let's see, it's going to be partial squared f with respect to x. Okay, so that was, let me get this mess out of here. That was if we took the derivative of this derivative with respect to x. Now we can also take the derivative of this with respect to y. So that would be f sub xy. So that's the derivative with respect to x, then y. Now here's where it gets a little confusing. Remember what we're doing? We're doing the derivative with respect to y of the derivative with respect to x. Now notice the order on the bottom here. So for this one, this is still going to be partial squared f, but it's going to be the partial with respect to y, partial with respect to x. Notice the order of the letters are opposite here. When you're reading it in differential notation, you say we're going to do this one first, then that one. So we're going to do the partial with respect to x first, then the partial with respect to y. with the subscript notation, you work the other direction. You do f sub derivative with respect to x first, then the derivative with respect to y. So that is the one confusing part about these two notations. They are a little bit backwards. Okay, so we took our first derivative with respect to x and found both of its second derivatives. Now I'm going to do the same thing with the derivative with respect to y. So I could take the derivative with respect to y and do the derivative with respect to y again. Again, kind of following our notations, that would be partial squared f, which was y squared. And I could take this derivative and find the derivative of that, f sub y, with respect to x. So that's going to be partial squared f, partial squared x, or partial y. All right, do a better job of drawing these scripty D looking things. Take a look at your book to see what they're actually supposed to look like. All right, so there's our notation. Now, it can be a little bit confusing. Most students tend to stick to this notation, just like we tend to stick to the prime notation because it's a little bit easier to write. But do make sure that you understand both. Well, now that we understand the notation, or have seen the notation, how do you actually find a partial derivative? Well, there's actually a lot of really good news here. By the way, I didn't write this. All of these, let me go ahead and put this up here real quick. All of these are our second derivatives. Some really good and kind of bad news when we're taking partial derivatives. The idea for a partial derivative is, since both of these independent variables are independent of each other, when we take a derivative with respect to x, we can ignore the y's, right? Because we're only saying what's happening when x changes. So when we take the derivative with respect to x, we're going to treat all the y's just like they're numbers, or just like they're constants. And same idea, when we take a derivative with respect to y, we're going to treat all the x's like they're constants. Okay, so let's do one or two problems here. We're going to do a bunch of these derivatives. So let's say the directions say find all the first and second derivatives. So very straightforward, find all the first and second derivatives. And let's say I gave you a function, f of x and y is 2x squared y cubed minus, I don't know, 4x minus 3y. Okay, let's start. And you can do these in any order you want. You do have to find the first derivatives before the second. So let's find f sub x first. So I'm going to take the derivative of this with respect to x, which means any y's are constants. So you can kind of think about this. Here I'm taking the derivative with respect to x, so the 2y cubed out in front is just like a number, right? So if I just said, what's the derivative of 5x squared? You'd bring down the power, take one away from the power, so that would just give me 10x, right? So if I take the derivative of this, now remember that's a constant, I bring that down, that's going to give me 4, I'm going to go ahead and write it as y cubed x for right now. But technically, right, we write our letters in alphabetical order, so that would be 4x y cubed. Now the derivative of negative 4x with respect to x is just 4. Now, the derivative of this with respect to x, well, there's no x's with it, which means it's a constant, and we know the derivative of a constant is 0. So that is our derivative with respect to x. Let's find our other first derivative, f sub y. So now, ignore this line, I'm looking back up the original, I'm taking the derivative of this with respect to y. Which remember, this 2x squared out in front is just a constant. So the derivative of y cubed is bring down the power, take one away from the power, minus the derivative of 4x with respect to y. There are no y's here, so that's a constant, so the derivative of that is 0. The derivative of negative 3y would just be negative 3. Okay, so those are our first derivatives. Let's see if we can find our second derivative. So let's try f sub x, x. So since we're doing f sub x, x, I'm looking at this line here, right? I'm going to take the derivative of f sub x with respect to x. So what is the derivative of this with respect to x? Again, remember, you're thinking that y cubed is a constant. So that's just like saying, what's the derivative of 7x, right? Because that's just a number. Of course, the answer to that's just 7. So the derivative of this with respect to x is just 4y cubed. And the derivative of a constant is 0. All right, let's move on to our next one. F sub xy. All right, remember this notation says find f sub x and take the derivative with respect to y. So I'm looking at this line right here. This is f sub x. I'm taking the derivative with respect to y. So 4x is a constant. So the derivative of just y cubed is bring down the power, take 1 away from the power. So when I bring down the power, it gives me 12x y squared. And the derivative of a constant is 0. All right, let's try another one. F sub yx. Let's do f sub yy first, sorry. That's the way I was doing it. F sub yy, right? We already did all of our second derivatives of the x one. So now we're going to do our second derivatives of the y. So f sub y, I'm going to go ahead and take the derivative of y again. So if I take the derivative of this with respect to y, remember the 6x squared is a constant. So the derivative of y squared is going to be 2y. So when you bring down the 2, that gives me a 12x squared y. And the derivative of the 3 is 0. All right, let's try f sub y. Let's take derivative of this. Now we need to take the derivative of that with respect to x. Okay, so we're taking the derivative of this with respect to x. So again, if you want to write it like this, this would be 6y squared x squared. So remember, that's a constant. So the only thing we're taking the derivative of is the x squared. So when we bring down the 2, that gives me a 12x y squared. Right? If you wanted to write it like this at first, right, this would be the derivative of that is 2x. And then when you multiply that and rearrange it, you get 12xy squared. Okay, so there's all of our first derivatives and all of our second derivatives. Now let's talk about two of these real quick. Notice that f sub xy and f sub yx actually ended up being the same. These actually have a special name. These are called the mixed partial derivatives. Why are they called mixed? Because we did the derivative of two separate variables there, derivative of x and the derivative of y. The only difference is what order we did the derivative, right? Here we did the derivative with respect to x, then with respect to y. Down here we did it backwards. We did the derivative of y, then the derivative with respect to x. Notice we ended up with the same answer. That's going to be a pretty good check for you when you're doing these problems. If you don't get the mixed partials are equal, one of two things will happen. Most likely you have made a mistake somewhere. Go back and see if you can find it. The only time that the mixed partials are not equal to each other is if the function's not continuous at certain parts, which you're most likely not going to run into much at this stage. All right, let's try one more of these and see how we can do. Let's start with a brand new function. Let's make it a little bit meaner. Later. So let's start with our function. Let's say our function is 2x squared y e to the 2x plus xy. All right, going to be a little bit uglier in places, but let's take a look at this. Do me a favor. Let's go ahead and get you tried. See if you can find all the first and second derivatives for this. Hit pause and see how you did. You back? All right, let's see how we did. Let's find the first derivatives. Well, first, so f sub x of x and y. Actually, you know what? Let's do the other notation. Let's do the partial of f with respect to x. So same thing, remember this is just f sub x. Now notice for this first piece, the 2y, since I'm taking the derivative with respect to x, is a constant, right? So I'm going to treat that just like a constant. How would I take the derivative of x squared e to the x with respect to x? Well, I'm going to write the 2y just out front. Here we got to do the product rule. So the derivative of x squared is 2x times e to the x, plus the derivative of e to the 2x is 2e to the 2x. So hopefully those are coming a little bit quicker for you now. If you need to write one as u, one as v, and put all the pieces together, go ahead and do that. Now when we distribute that 2y back in, I'm going to get 4xy e to the 2x plus 4x squared y e to the 2x. Okay, so that's the derivative of the first term with respect to x. The derivative of the second term with respect to x, well, the derivative of x is just 1 times y would be y. All right, messy. So now let's see if we can find the partial of f with respect to y. So again, we're looking back at the original. So with the original, really we just have, I'm gonna write it like this, 2x squared e to the 2x times y. So all of that x stuff is a constant. So the derivative of y is just 1, 2x squared e to the 2x. And the derivative of xy with respect to y, the derivative of y is 1, so my answer there is just x. All right, let's go through and try the second derivatives. So I'm going to do the second derivative with respect to x. So this one's going to be pretty messy. We're going to have a lot of work to do. We've got to take the derivative of all of these with respect to x. Now for each one of these, we're going to have to do our product rule. So I'm going to take this first term and I'm going to bring the constants out front. So that's 4y times, that's, what do we have there? X e to the 2x. Okay, so the 4y is a constant. When we take the derivative of this, we're going to do our product rule. The derivative of x is 1 times e to the 2x. The derivative of e to the 2x is 2e to the 2x. So when we distribute the 4 there, we get 4ye to the 2x, 8xye to the 2x. Okay, so that's the derivative of the first term. For our second term, we got to do basically the same thing. So for our second term, the 4y is a constant. This time we have x squared e to the 2x. We have x squared e to the 2x. When we take the derivative here, 2x plus 2x squared e to the 2x, and we distribute, we get 8xy e to the 2x plus 8x squared y e to the 2x. So again, if you're still doing the u-v thing, that's fine. Just go over to the side, pick your u, pick your v, and then put it together. So that's the derivative of the second term. So that's plus 8xy e to the 2x, 8x squared y e to the 2x. Now remember, we're taking the derivative of this line right here with respect to x. The y here, the derivative of y is a constant, so the derivative of that with respect to x is 0. Now notice, that was kind of messy. We had to do the product rule a couple times, but we can actually also combine some like terms there in the middle. So we get e to the 2x. These two things are the same thing. We have 8 and 8, which means I have 16xy e to the 2x's plus 8x squared y e to the 2x. Okay, so that's the second derivative of f with respect to x. Now, what if I take the derivative of this now with respect to y? So it's still going to be the second derivative of f, but we're going to take the derivative with respect to y with respect to x. So we're going to do the derivative with respect to x, and we're going to take the derivative of that with respect to y. So the derivative of this with respect to y. Notice in this first piece, the only thing that has a y is this one piece right here. So we can think about this as 4x e to the 2x times y. The derivative of y is 1, so this is just 4x e to the 2x. The derivative of this with respect to y, the same thing's going to happen, right? All the x stuff's a constant, so the derivative of this piece is just going to be 4x squared e to the 2x. And the derivative of y with respect to y would be 1. Okay, so that's the two second derivatives of the derivative with respect to x. Now let's take this one and let's do the derivative with respect to, let's do the derivative with respect to y again. So the second derivative of f with respect to y. Well, this doesn't have any y's in it. So the derivative of this, that's all a constant, is 0. Now if we take that, the derivative with respect to x, and our derivative with respect to y, and then take the derivative with respect to x. So I'm looking at here, and I want to take the derivative with respect to x. Well, for this first piece, we're going to have to do the product rule. So the derivative of 2x squared will be 4x times e to the 2x. The derivative of e to the 2x is 2e to the 2x, so that gives me 4x squared e to the 2x. And the derivative of x with respect to x would be 1. Now we should always do this at this stage, do a quick little check. Do the mixed partials equal each other? Well, there's one mixed partial, there's the other. Notice they're the exact same thing. Therefore, we can probably say, yeah, there's a real good chance that we got this right. So, the big idea from taking partial derivatives is, whatever letter you're taking the derivative with respect to, all other letters are constants, and you treat them exactly like you would constants.